Hi everyone, welcome to another TechNote session. In this session, we are going to discuss spanning tree. What is spanning tree? What are the types of spanning tree? Why do we need a spanning tree? How it is working? How can we verify a spanning tree? Let's begin. What is spanning tree? The spanning tree protocol is a network protocol that builds a loop-free logical topology for Ethernet networks. What it means? Which means in a LAN, spanning tree protocol creates a logical topology which doesn't have redundant path between the switches. Why do we need that? Why do we need a spanning tree? Spanning tree prevents layer 2 loops in a network. How is that working? A bridge loop occurs in a computer network when there is more than one layer 2 path between two endpoints, which means consider you have two computers. PCs are connected separately in two switches. First computer is connected to first switch, second computer is connected to second switch, and there are two physical cables connected between the switches. So when first computer is sending a ARP request, it broadcast, and second switch receives from two sources. There is a confusion there. Same request came from two sources. That is number one. Second, when a request received in a switch, it broadcast again. So port 1 receives a request, it broadcasts. Port 2 received another request, that also broadcast. So it again going back to the switch 1. So problem number 2. Third, it receives on right destination, but it broadcasts again. So it makes broadcast tone, MAC address instability, multiple frame transmission, misinterpretation. So all these problems we can solve by having a spanning tree. How a spanning tree is working? There are three steps involved in it. First, elect the root bridge. Second, find the best path to the root bridge. Third, block the redundant path to the root bridge. First step, elect the root bridge. How it's finding a best root bridge? So it checks for the lowest bridge ID, which is a combination of bridge priority and MAC address. So bridge priority, it's a 16-bit information. By default 32,768 it's coming for. And MAC address, it always prefer the lowest MAC address. So always old switches finds the best bridge in a network. So that is the reason we are manually setting a root bridge to fine tune our things. Second step, find the best path to the root bridge. How it is working? There are three steps involved in it. First, lowest cost, lowest bridge ID, and lowest port number. How is that? Lowest cost, every link have a different cost. In first scenario, which I have illustrated, it got a gig link, gig Ethernet link, which got cost of 4. So imagine a switch wants to reach the root bridge. After root bridge selection, a bridge switch wants to reach the root bridge. It checks for the multiple path, and it checks in each path how much cost is involved in it to reach the destination, which is root bridge. So in that scenario, if that switch is finding all the cost, all the links have same cost, which you can take the second scenario, the down switch, he wants to reach the top root bridge, so it got same cost to reach the root bridge from all the possible way. Then it goes for the lowest bridge ID. So what it checks is in the neighbor switch, what are the hops involved in it. So how much cost it takes, and what are the IDs involved in it. So in that case, different switch have a different bridge ID. So what it checks for the lowest bridge ID. So it prefer the lowest bridge ID. That path always win. And in other scenario, third scenario, it checks for the lowest port number. So which means, if imagine it got a same cost, same bridge ID, and it got multiple paths. So how it prefers the port, which port number? So it always checks from the root side. It won't be the local port number it checks. So in our scenario, the third picture, if you can check, it got gig 0/0/1 and 2 are connected to another switch. So we are the downward switch. So from downward switch to topward bridge switch to reach, it have a same cost, and bridge ID is same. So it has to check for the lowest port number. So it always wins from the port side of the route, not from the bridge. Okay, and the last process is to block all the redundant path. So at the end, a switch will have only one logical path to reach the root bridge. How a spanning tree works: after root bridge election, every switch must have a best path to the root bridge. So I have created a topology here with the 3 switches: switch 1, switch 2, switch 3. Got same priority and different MAC addresses. So switch 1 is the root bridge in this scenario, and let's imagine from switch 3 how a cost is evaluated. So this connectivity is based on gig Ethernet. So we are using a gig Ethernet. So it got value of 4. So switch 3 wants to reach the root bridge. If it's taking gig 0/0/1, it costs 4. If it is taking gig 0/0/2, it cost 8. Like it has to go to the switch 2, and from there it has come back to switch 1. So it always prefer the best path, which is lowest cost. So it's going to take a gig 0/1. So there he finalized, because no more. This another scenario which comes for the bridge ID and all, when the cost is same. So in this scenario, it will prefer gig 0/0/1 and block the remaining. So the remaining port is gig 0/0/2. What are the port states? There are 4 port states: blocking, listening, learning, and forwarding. In a normal scenario, when a link came up, it will be in blocking state. So from blocking to complete listening state, it takes 15 seconds. And from learning to forwarding, it takes another 15 seconds. So total 30 seconds it will take to complete the convergence. So second scenario, which is a BPDU loss from root bridge or superior BPDU detected. So in a blocked port, if it start losing a BPDU or receiving a superior BPDU, then it waits for 20 seconds, which is the max age timer, which is actually 10 hellos. It waits. Then it moves to it will move to the listening state, then from the learning state, and then forwarding. So it takes 50 seconds to complete that state. So that is in BPDU loss or superior BPDU detection scenario. And in normal scenario, it will be 30 seconds. Spanning tree types: common spanning tree, per VLAN spanning tree, rapid spanning tree, rapid per VLAN spanning tree, multiple spanning tree protocol. These are the various types we have. Common spanning tree: one logical topology for entire LAN. Per VLAN spanning tree, which got multiple topology for different VLANs. Like let's say you have 100 VLANs. In common spanning tree, you will have only one, but in per VLAN spanning tree, we can have various. So let's go to the rapid one. Rapid spanning tree differs from the common spanning tree and per VLAN spanning trees. It actually we can compare with common spanning tree. So compared to common spanning tree, rapid spanning tree does not wait for forwarding delay. Like it doesn't have forwarding delay. Like in a scenario, a link failure occurred, it will not go to listening, learning. It directly go to from blocking to forwarding. So we can save some time. So that is a benefit we have in rapid spanning tree. Then comes rapid per VLAN spanning tree. It's an add-on for per VLAN spanning tree with rapidness. So which means it will not wait for listening and learning. It directly goes from blocking to forwarding, but it got the per VLAN things. So it's an add-on for like a per VLAN plus rapid. Then comes multiple spanning tree protocol, which is commonly seen in network. Like let's say we have various topologies, so it consumes a lot of resource to manage this spanning tree for different VLANs. So what it does is, multiple spanning tree does is, it groups the instance. Like let's say instance 1 have a couple of VLAN and it got one topology. Instance 2 got a group of VLAN, it got different topology. So we can design in such a way one topology, one instance for one topology and other instance for another topology. So the resource consumption is very less compared to others. So this is the main benefit we have. And in reality, I have seen mostly multiple spanning tree protocol and per VLAN rapid spanning tree mostly. Let's take a spanning tree configurations, root bridge configuration. So let's say you want to enable rapid PVST, rapid per VLAN spanning tree. Go to global configuration mode, type spanning tree mode rapid PVST. You can enable rapid PVST. Let's say you want to enable spanning tree on VLAN 100. Go to global config mode, spanning tree VLAN 100. This is a command. And let's say you want to make your core switch 1 as a root bridge primary. Then go to global configuration mode, spanning tree VLAN 100 root primary. Let's say you want to make a core switch 2 as secondary for VLAN 100. Then go to global configuration mode, spanning tree VLAN 100 root secondary. Spanning tree show commands. There are set of commands which you can verify. Use show spanning tree root, which displays the information of the root bridge. Show spanning tree, which displays the information about the spanning tree. Show spanning tree active, which displays information about spanning tree active interfaces. Show spanning tree bridge displays the bridge ID, timers, protocol for the local bridge on the switch, all this information. Show spanning tree brief is the another command which commonly used, displays the brief information about the spanning tree. Next is spanning tree details, displays the whole information about spanning tree. Show spanning tree interface, displays the spanning tree interface status and configuration of the specified interface. So the next is spanning tree MST, which is used for multiple spanning tree, which shows the MST details. And the next is spanning tree summary, which gives a summary about spanning tree. And the other one is spanning tree VLAN, displays the STP information for specific VLAN. So all these are the show commands which we can use based on our requirement, what we feel to have information about what is happening. So this is the brief information about spanning tree. So for learning about rapid spanning tree and MST, you can watch a separate video with the labs, which is available in a YouTube channel. So I hope it was informative to you, and I would like to thank you for watching. Thank you.